Yo folks, ready to dive into the world of real-life transformers? You've seen me in movies, but meet my cousin, the distribution transformer. It steps down high voltage for everyday use. Pretty cool, huh? And now let's understand its connection in the distribution grid. Stay charged, folks.
So this is pole-mounted distribution transformer which converts 11 kV volt into 3-phase 440 volt for domestic purpose. So I have clicked one distribution transformer which is of H type. H is because this is forming a shape of H, and here our distribution transformer is being placed over here. So that's why it is being called as the H type distribution transformer. And by looking at this picture, the first four things which catches our eyes are: the number one is the radiator, the number two is the tank, transformer tank, and the third one is some wiring is coming out or coming in the transformer. Similarly, some wiring or some connections are coming in or coming out in the transformer. So we cannot able to differentiate that which is the incoming and which one is the outgoing. So to understand this, let's have one by one look at the number one thing is, which is the radiator. This is being used in the transformer just to cool down the oil which is being placed inside the transformer for the cooling purpose. So the transformer has oil being filled in this core inside it, and the windings are submerged inside the oil, the transformer oil, and the radiator is just provide extended surface area for this oil to dissipate its heats in the surroundings. So this is the area which is providing a more surface area in the surroundings to dissipate the heat in the environment. And the similar kind of a methodology is being used inside our vehicles. The same kind of a radiator is being placed, and the purpose of this radiator is also same inside the vehicle, just to dissipate the heat. The number 2 and 3 are nothing but the conservator tank and the incoming supply and the outgoing supply. So the conservator tank is to provide the passage for the oil which is being filled inside the transformer core, transformer. So when oil inside the transformer tank gets heated up, because the windings are submerged in this, and when we have the applied voltage to the windings, it produces the heat because of the I square R, and this heat is being taken by the oil, and when the oil get heated up, it gets expanded and it goes towards the conservator tank. So this phenomena provides a way by which we can reduce the pressure which is building up inside the transformer tank over here. So that's why the conservator tank is being used. And the third and the fourth, here we can see that some windings or some cables are being either coming out or they are going in. Similarly, the fourth one. So to understand that which one is the incoming and which one is the outgoing, so let's take the other view of this picture. So from this side, we can see that overhead wires are coming, either they are coming or they are going from transformer towards the up pole. So it is very difficult for a beginner that to understand that which is the incoming and which one is the outgoing from the transformer. So here this can easily be identified with the help of the bushings of the transformer. So these are the bushings which is being placed over here. So these are the bushings over here, and whenever we talk about the distribution transformer, so it is always provides a way to step down the voltage. So whenever we stepping down the voltage, so a high voltage is being converted into the low voltage level. So therefore the bushings which is having the more cross-sectional area, so here we can see that these bushings are more in the area and they are more in the diameter. The bushings are directly proportional, the bushing size are directly proportional to the voltage. So therefore it is definitely for the higher voltage side bushings, and by this we can easily identify that this is the incoming which is coming from the overhead. So these are the phases from the overhead wires is coming, and they are of the 11 kV voltage over here, and then by the meanings of the isolators, and then coming down to the high voltage bushing over here. So if we'll just take the another view of the overhead wires which is coming down to the transformer. So these are the high voltage lines of 11 kV overhead lines are coming, and they are connected through a pole. They are connected to a pole through an insulator. So these are the 11 kV insulators of rubber type. They are placed over here, and then from here the three phases are going to the bushings. They are going to the insulators which is connected to the H type transformer pole, and then these three phases are going down towards the high voltage bushings of the transformer. So again in this picture we can see that the overhead wires 3-phase 11 kV are coming to H towards the H pole, and they are connected through again insulators, because the wires cannot be in the direct contact with the pole, otherwise it will create electrocution to any human being or any other life. So therefore all the overhead wires or all the wires are being connected through the insulators, and then from here the wires are coming down, and they are connected again through some kind of a insulators. And this phenomena here which is being shown over here is these spiral windings again coming, and they are connected to the insulators over here. The three phase are coming like this, and then from this insulator to this insulator a very thick, comparatively thick wire is being connected between these in this fashion, and then from here the wires, incoming wires, are connected to the high voltage bushing side of the transformer. Why we do the thing is towards comparatively using the thin wire over here is because it provides same kind of phenomena which is being used in the fuse. So if we have any kind of a fault, and let's say that the current is being increased due to any kind of a fault, so these wires which is being connected over here, which is the comparatively thick, they get melt down because of the I square R, and then the circuit gets open from here. So the same thing is being provided in the fuse. So similar kind of a phenomena is being provided over here for the production purpose, and these spiral wind kind of a shape is given to provide the strength of the wire which is coming down towards the insulator, because they are the hanging wires and it should not get in touch with the pole and the other part of the pole. So therefore to provide this strength, there it has been provided in the terms of this spiraling of there, and from here it comes down to the high voltage bushing side. And from here we can see that this is the outgoing 440 volt supply, because this is the transformer of the 11 kV and step down the voltage to the 440 volt. So therefore this is the outgoing which is going for my residential load purpose. So if we zoom out the previous picture, now we can clearly see that the incoming of 11 kV are connected through this insulator, and these wires is being placed in this spiral shape just to provide the more strength, and this wire comes down to here, and then the connection between these two insulators, which is connected through a thin type of wire, is being connected here. So this wire gets heated up, and that means it gets melt down in case of the heavy current which is due to any kind of a fault occurring phenomenon.
Hi, I'm Mr. T, your friendly neighborhood transformer. And no, I don't turn into a car, but I do something cooler. I step down 11,000 volts to a comfy 440 volts, so your home can safely use all that electric power. Imagine trying to charge your phone with a lightning bolt. Yikes, that's where I come in. I take those super high volts and bring them down to a level that won't fry your circuits, so I'm like a power bouncer, letting in just the right amount to keep the party going. Without me, you'd have a lot of fried electronics and zero Netflix. So next time you flip a switch, give a nod to Mr. T, keeping your home powered and your gadgets happy, 1 volt at a time. Remember, no need to stress, I've got the power. Thanks for watching, and keep those volts in check with Mr. T.